All right, guys, let's go ahead and look at Intro to Matrices. So, I think a lot of you guys have seen these before, but if not, that's okay. A matrix is numbers or data that's organized. So each different piece, we call each of these little pieces here, these are each called elements. Okay, so each of these is called an element. And I can ask you a couple different things. So first thing I could ask you is I can ask for your order of your matrix. Okay, when you look at your order, your M rows and N columns. You're an M by N. So here, if I'm looking at this, this has 3 rows, 1, 2, 3, and 4 columns, 1, 2, 3, 4. So I can say that this is a 3 by 4 matrix. So look at these. State the dimensions of each matrix. So again, we want row by column. Okay, so I'm going to look at my rows. I have 1, 2, 3, 4 rows. And I'm going to have 1, 2, 3 columns. So this is going to be a 4 by 3 matrix. If I'm looking here, I have 1 row. And I have 1, 2, 3 columns. So this is a 1 by 3 matrix. Okay, so I'm going to ask you to do some operations with matrices. First, I want you to solve each equation. So the really cool thing with this is matrices. If I have one equal to the other, then I know that the element that's in the same spot of each matrix has to equal the other element in that same spot on the opposite matrix. Because this is a 2 by 1 and a 2 by 1. Since they're equal, I know that the element that is in the first spot and the first column in the first row has to equal the element that's in the first column and the first row of the second matrix. So I can go ahead and I can look at setting those equal to each other. So I have negative 4x minus 3 is going to equal negative 3x. And then you're just solving a linear equation. So add 4 over that 4x, add that 4x. So I'm going to get x is going to equal negative 3. So that's going to be my first one. And now I can use the matrix. The second row, first column, has to equal the second row, first column in the other one. So I would have 2y plus 3 equals negative 2y plus 16. Everything with a y to one side. Everything without to the other. Okay, and now we're going to divide by 4, divide by 4. So y is going to equal 13/4. All right, let's look at number 4 here. So I know that the first element in the first row, first column will have to equal the element in the first row, first column of the other one. So if I am writing this out, I'm going to have 3x minus 2 equals 7. Now it's just a linear equation. So I'm going to get 3x equals 9. X will equal 3. All right, this one, same idea, you guys. So I have, in this situation, there's no adding or subtracting happening in these pieces. So these are each their own column. So I have a 1 by 3 and a 1 by 3. So I'm going to say, well, the element that's in the first row, first column has to equal the element in the first row, first column. So I'm going to end up with 2x equals 10, and I'm just solving. So x is going to equal 5. And now I'm going to go ahead and I'm going to go to the second column, first row. Second column, first row, and I'm going to solve that. So I'm going to have negative 8y equals 16. So y will equal negative 2. And now I'm going to do the same thing. Third column, first row, third column, first row, tells me right away z is going to equal negative 1. Next problem here, I can do the same idea. So right now when I'm looking at this, I have a 2 by 2 and a 2 by 2. So I know first row, first column, first row, first column. Those are going to equal each other. So 3x plus 1 equals 7. 3x is going to equal 6, so x would be 2. Hopefully I'm not going too fast for you on this. Next one I can look at here, I can say second row, first column, second row, first column. Well, 12 equals 12. That's done. There's nothing I can do there. Okay. Second row, second column, second row, second column. I can say I have 18 equal to 2y minus 4. 22, so y is going to equal 11. And then last but not least, I can say, well, I have 4z equal to 28. You can solve that. So 4z equals 28. So z is going to equal 7. All right, so next thing that we're going to look at here is adding and subtracting matrices and then multiplying by matrices. So first thing you need to know, in order to add and subtract matrices, they need to be the same dimensions. If they are not, we can't do it, and we're just going to write down impossible. For scalar multiplication, so I can multiply a matrix by any number. I just multiply every element in that matrix by that number. So here is what we're doing, performing the following operations. If it doesn't exist, write impossible. It is asking me to do a plus b. So I'm going to look at a, which is a 2 by 2, and I'm going to see if I can add it to b. B is a 2 by 2. They are the same size, 2 by 2, 2 by 2. So I can go ahead and I can do this operation. I can take A, so 3, 4, 2, 3, and I can add to it B, so 2, 1, 2, negative 2. So this is just like before when we did this, we're just going to add each element that's in the same spot together. So 3 is in the same spot as 2. We're going to add them together. So I'm going to get 5. And then I'm going to have 2 in the same spot as 2. So I'm going to have 4. Then we'll have 4 in the same spot as 1. Add them together. I'm going to get 5. And then we're going to have 3 in the same spot as negative 2. Add them together. I'm going to get 1. So A plus B is going to equal this matrix right here. Now it wants us to do A minus B. Again, they have to be the same size in order to do it. So it's a 2 by 2. Therefore, I can. So I'm going to do 3, 4, 2, 3. And we're going to minus B. So 2, 1, 2, negative 2. Same idea. 3 minus 2 is going to give me 1. 2 minus 2 is going to give me 0. 4 minus 1 is going to give me 3. 3 minus negative 2, when you subtract a negative, you're adding, so I'm going to end up with 5. This has a little multiplication going on. So what it wants me to do first is it wants me to multiply 2 times A, and then multiply 3 times B, and then add those together. So when you're multiplying, everything in that matrix gets multiplied by that number. So my 2A is actually going to end up being 2 times 3, 6, 2 times 4, 8, 2 times 2, 4, 2 times 3, 6. I just multiplied everything in here by 2. Now I'm going to have 3 times B, so I can add those together. So 3 times everything in there. 3 times 2 is 6, 3 times 1 is 3, 3 times 2 is 6, 3 times negative 2 is negative 6. I just multiplied it by everything in there. Now, check to make sure they're the same size. It's a 2 by 2, 2 by 2. I can multiply, or I can add these together now. So I'm going to have 6 and 6, 12. I'm going to have 4 and 6, 10. 8 and 3, 11. And then I'm going to have 6 and negative 6. So 0. Let's look at this one. It wants me to do A plus C. So I have a 2 by 2 and a 1 by 3. Because they are not the same size, I cannot add those together. So this is an impossible situation. All right, that's it for today. Go ahead and do that assignment and then get it checked off. Good luck.